Hello. In this video, we're going to be introducing the concept of a vector. Now, a vector is a line segment that has a very specific direction and a very specific length for it. So notice in my example, I have a vector that starts at point P, that's the initial point, and it ends at point Q, the terminal point. So it has that direction from P to Q, and it has the length between those 2 points. Now, the length of a vector is called the magnitude, and it can be denoted with those 2 vertical lines on either side of the vector's name. We find the magnitude just by using the distance formula. However, the direction is an angle created between the vector and a horizontal line. So our initial point is point P, so to find the direction of this vector in degrees, we would draw our horizontal line and then find the angle between those 2 rays or 2 vectors. Any 2 vectors that have the same magnitude and direction are equivalent. They may be in different locations, but with the same magnitude and direction, they are equivalent vectors. Another way we could denote a vector is with just a lowercase bolded letter. So I have the bold-faced letter V here that could also be used to represent vector PQ. So we could also call this vector V. All right, let's do an example. In this example, we want to find the magnitude and direction of a vector. It has an initial point at -2, 5 and a terminal point at -3, 6. So just to give ourselves a rough sketch of this, so here's our coordinate plane. And if we put a point roughly where -2, 5 is, and then a point at -3, 6, there is our vector. So the magnitude of this is simply, and I'll call this vector V. So the magnitude of V is going to equal, well, we just do the distance formula to find one from the next. So we subtract our x's squared, we subtract our y's squared, and figure out that value. So -2 minus -3 is 1. 5 minus -6 is -1. And so the result ends up being the square root of 2. And that is the magnitude of our vector. That's its length. Now the direction, let me draw this a little bit bigger. So to find the direction, we draw our horizontal line out to the right. And we want to find this angle right here. So we want to find angle theta. Now, the best way for us to do that, if we drop a vertical line and then continue a horizontal, and we find this angle theta prime, we know that our vector's direction, theta, should be 180 minus theta prime. So it's just a matter of looking at the vector, realizing which direction it's facing, and should you compare it to 180 or 360 or neither. So it's going to have a little bit of problem solving here based on how the vector looks and what you need to do. So to label this information, we know we went left -1, we went up 1 to get from one side to the next, or from the initial to the terminal. For now, I'm actually going to ignore the negative because I want a theta measure, a theta prime measure that's going to be somewhere between 0 and 90 degrees, and that I can take 180 minus that value to figure out our theta. So to figure out theta prime, we know opposite and adjacent, so we're going to use tangent. Tangent of theta prime is opposite 1 over adjacent 1. So that tells us that the inverse tangent of 1 over 1 is going to be theta prime, and the inverse tangent of 1 over 1 is 45 degrees, which means that theta is going to be 135 degrees. And that is the direction of our vector. It's 135 degrees is the direction it's facing or heading, and it's got a length or magnitude of the square root of 2. Okay, that's your introduction to vectors. For now, we are done.